Connecting. Yeah. Welcome back. Hello, Alberto.
Hi, nice to be here, guys.
Alberto is a developer relations manager at PureStake and Moonbeam. So as I mentioned before, he's gonna give you some more background and info about bounty sponsored by Moonbeam. So yeah, Alberto, the stage is yours.
Thanks for the presentation. Truly happy to be here. Hopefully you guys hear me well. And yeah, I'm gonna talk to you today about Moonbeam, which is a smart contract platform that is Ethereum compatible on the Polkadot ecosystem. I didn't do like a whole technical, huge technical demo or presentation. What I'm gonna do is provide some slides for you to get to know Moonbeam, and also some dApps examples that we've built on top of our testnet. So I guess you can see my screen now. So yeah, before actually I go into the presentation, I just want to do a very quick demo, right? If you're familiar with the Ethereum environment and an Ethereum developer, and you're an Ethereum developer, you might have known Remix. So Remix is a web-based browser-based tool to compile and deploy smart contracts. As you can see right here, I have an ERC20 token contract from the OpenZeppelin code base, and I'm going to deploy this ERC20 called 0x hack moon, and then 0x moon as a symbol. And I am already connected. The contract is already compiled. I'm going to go ahead and deploy. You will see that I have a MetaMask pop-up. I have super zoomed in so you guys can see, and I'm going to go ahead and confirm this transaction. So this is a typical kind of like workflow when you're working with Remix and with OpenZeppelin or any kind of like a smart contracts on Remix, and you're using MetaMask as a Web3 provider for Remix, right? You can see, you cannot see it, but you can see down here that my transaction has already been confirmed. I can go down here and check my ERC20 token contract, as you would expect. I can go ahead and copy the address, go to MetaMask, paste it here, and import the token to MetaMask, right? So the whole, there's a trick behind all this, right? And what if I tell you that all the steps that I just did are not against, Rinkeby or Coven or any like Ethereum kind of like technology stack-based node, right? But it's against Moonbeam or a testnet Moonbase Alpha, which provides a very friendly and Ethereum-compatible environment, but it's built on a totally different technology stack, which is Substrate. And this is what I'm going to present to you today. It's what is Moonbeam, right? So, today's agenda is going to be a little bit introduction about Moonbeam, and I brought a bunch of dApps examples that we've built on top of our testnet just to provide some ideas for the hackathon. And we're not going to go through the code because all the code is usually available on our GitHub. But we're going to see a little bit of what is the difference between a dApp on Moonbeam and a dApp on Ethereum. And just to give you a preview, there's actually not much difference. Oh, and by the way, feel free to ask any questions on the chat. I'm looking into it on the other screen so I can answer any questions you might have. So yeah, the first question is what is Moonbeam, right? And Moonbeam is a smart contract platform that it's built on top of the Polkadot or Kusama ecosystem. So as a smart contract, Ethereum-compatible smart contract platform, we do have an EVM, but the EVM is just like the base layer of all the stuff that we've built. On top of that EVM, we have different stuff that we've added over the time just to provide the most seamless or frictionless Ethereum-compatible environment you might find on the Polkadot or Kusama ecosystems. And this means that we support the token and infrastructure integrations. We have modified the Substrate underlying account system so that everything is standardized as an Ethereum account and key format. We're compatible with Ethereum-based tools that you just saw with Remix and MetaMask, for example. And you can deploy Solidity smart contracts. And we also provide some composability between the contracts, right? Just if you're curious, the name Moonbeam comes from the Jazz standard Polkadots and Moonbeams. So we believe that a multi-chain strategy makes sense because there are three main topics. I'm going to only discuss two of them for time constraint purposes. But a multi-chain strategy makes sense because on one side, we have the lost market opportunity. This means that a lot of users or use cases are being priced out of Ethereum L1 due to high gas fees, right? And even though gas fees have reduced a little bit in the past month, we're still seeing that deploying a smart contract can cost $200, $300 depending on the gas. So a lot of these projects are just priced out, right? A good example that I like to provide is that, let's say I am a DApp that needs to roll a dice on chain with a VRF or whatever, and it just costs $20 to roll a dice. I mean, this is something that is not feasible for a lot of projects. But more importantly, or also more interestingly, is that you can be a first movers in new markets. This means that your project can draw new users and gain access to assets that are not native on Ethereum. And we're not talking only about DOT and KSM, but also a growing list of new parachain-based assets. So all the blockchains that will live under the Polkadot or Kusama ecosystems are called parachains, and they will all have a lot of assets that are just new, right? And one of the cool things about Polkadot or Kusama is that these blockchains called parachains will be able to communicate with each other on a native level. And this means that if you deploy your contract to Moonbeam, your project will have access to all the assets that are in the Polkadot or Kusama ecosystem, not only Moonbeam. So basically, a multi-chain strategy looks like this on Moonbeam, right? So let's say you have your Solidity or Viper, anything that compiles to EVM bytecode, your contracts here, and you can actually deploy them to Ethereum, but you can also deploy them to Moonbeam and basically access the whole Polkadot ecosystem, and Moonbeam can act as a gateway for that, right? And one example, one really straightforward example is that, let's say that you have your project already configured on Truffle or Hardhat or any other tool. You can just change the provider and just basically switch from the deploying to Ethereum to deploying to Moonbeam. And depending on how you basically configure your Truffle deployment, it could be a matter of like minutes or seconds, right? To deploy them to Moonbase Alpha or testnet and just start getting everything tuned up for a multi-chain deployment. Some of the projects that are working on Moonbeam are SushiSwap, Balancer, Ocean, Chainlink, Human Protocol, and others that we have a growing list of a really big ecosystem that we're truly excited about what we're building, right? So if you want to read more information about the projects, feel free to go to our website and you'll find a lot of the information there. So a question that a lot of Ethereum developers might have is, and they can be a little bit of skeptical, right? Because we know that they're used to working with Ethereum tools and Ethereum environments, such as Ethereum itself or BSC, which is still like a fork of Ethereum. But how do we bring Ethereum compatibility features to a Substrate-based tool? So Moonbeam is built using Substrate, which is a framework built by the Parity team in Rust, and a lot of projects might just be skeptical, right? So how is the experience? What is the experience going to be when you're dealing with Moonbeam? So before we go into this, let's just do a very 1-minute recap of how the Ethereum Json Rpc works. And this is how basically a lot of these tools such as MetaMask, Remix, Truffle, and Hardhat communicate with an Ethereum node, even though they might use some underlying libraries like Web3 JavaScript or Ether.js, right? So basically what they do is that they create a request where they're actually asking some sort of information, and the Ethereum node understands that request and provides a response. So let's say MetaMask wants to know the balance of an account. It will say, hey, I want to know the balance of this address, and the Ethereum node will provide a response with the balance, right? Basically on Moonbeam or any Substrate-based parachain, the main kind of feature that provides Ethereum compatibility is called Frontier. And this is my favorite definition of Frontier because it's the one that it's just easier to understand, is that Frontier will be like a middleware between Ethereum users or developers and Moonbeam, which is the Substrate-based parachain, right? So everything the Ethereum user and developer won't have to really wonder how do I interact with Moonbeam. They'll just use their regular tools, the regular user experience, and Frontier will act as a middleware that will translate from Ethereum language, let's say it like that, to Substrate language, right? And the point of Moonbeam, or what we're trying to achieve, is that if you at any moment hit a roadblock, or you say, hey, this is not like it was on Ethereum, we're not doing our job well. And this is exaggerating a little bit, but this is what we're trying to aim for, right? And so Frontier is like a key feature in playing this kind of role, that it just provides like a black box definition where you don't have to understand what it is, but it'll be the element that will provide the seamless or frictionless integration. At a more deeper level, how Frontier works is that any Ethereum JSON RPC or Ethereum development tool will interact with the RPC extension that provides a Web3 compatible API. And it basically maps everything to Substrate runtime calls. So that is why developers don't really need to worry, because Frontier will do everything for you. We also have what is called Pallet Ethereum, and Pallet Ethereum emulates block processing, store, invoke transaction logs, and dispatchers to the EVM backend. So these two components are actually what provides like an Ethereum-compatible API and kind of like experience. We also have a Pallet EVM and the Rust EVM, which are basically the two components that provide EVM compatibility. So one thing is an API, and the other thing is the EVM compatibility. But basically, at a very high level, these are all the components that provide an Ethereum experience on the Polkadot or Substrate, basically, technology. So what does this mean, right? So this is a lot of jibber jabber. What does this mean at a more practical terms? And basically, what this is that let's just use an example, right? If we go through the Ethereum wiki Json Rpc API, basically this URL that you see right here is our testnet open URL HTTP endpoint, and we're building a JSON RPC blob here where we're actually using the get balance method, and we're passing an address, right? And we're asking basically what we're doing is asking the node to tell us the latest available balance of this address. And the response from Moonbeam will be this, and this is exactly the response that you will get from any like Ethereum node, or if you're using Infura or Alchemy, this is the response that you will get. And this is basically almost 50 dev tokens, which is our testnet token, and of course in hexadecimal and in weight units. So this is, once again, what basically MetaMask is doing all the time. If you actually see the logs, you basically see that MetaMask is asking the balance of all the accounts that are available in MetaMask, is asking for the block number, the chain ID, just to make sure constantly that you're connected to the right place, and the balance is getting updated as fast as possible. And this is mind-blowing because what I mentioned before, right? This means that developers don't really have to worry about, oh, Jesus, this is Moonbeam, this is a different technology, I'm a little bit skeptical, how do I get started? Another important thing that it's really important to understand is that there are a lot of like EVM-compatible parachains out there, and we've, once again, pushed really hard into providing a seamless or frictionless Ethereum-compatible experience. And unified accounts is one of these features that separates ourselves from other parachains that are offering EVM on Polkadot, EVM compatibility on Polkadot. So unified accounts, remember what I mentioned before, that any parachain that uses EVM Pallet, Ethereum Pallet, and Frontier is able to provide kind of like this Ethereum-friendly environment, right? But without unified accounts, this is more or less what it looks like in this kind of like baseline setup. Let's say a user, let's call her Alice, right? If she wants to interact with the EVM or the Ethereum side of things of our like blockchain, she'll need a private key, a normal private key to sign transactions, and that private key is related to an H160 address, which is the Ethereum style address, right? And with this combination, she can actually sign transactions and deploy contracts to the EVM side of things, right? And mathematically, this address can be mapped to an H256 address, which is the Polkadot-based style of address, right? And she can actually do read operations, for example, of the balance. The problem is that the private key is related to the H160 address and not the H256 address. So it's related to the Ethereum address and not the Polkadot-based address or Substrate address. So the problem is that she cannot do any transactions on the Substrate runtime, okay? So for her to do that, she'll need to actually create another account where she'll have a private key, a different private key that is related to an H256 address. And because she knows that private key, she can actually sign transactions related to the Substrate runtime. And those are really important transactions because they are related to governance or democracy and staking features. So let's say Alice wants to deploy EVM stuff or the Ethereum smart contracts. she'll have to use a private key, right? And for governance or staking, she'll have to use another private key. And this creates a lot of friction because she'll have to wonder about two different balances and transfer balance from one place to another. And it's hard, right? It just creates some friction. So what we did in Moonbeam is that we modified the Substrate underlying account system, and we made everything work with the H160 address and private key pair, right? So you'll be able to do not only the Ethereum side of things with your H160 address, but also to do staking and governance with your private key and H160 address on the Substrate runtime. And this is something that you can actually do right now on our using the Polkadot.js interface with your account that you got from MetaMask. You can import it there and just do staking and do governance in our testnet. All right, so let's go to show you some stuff around Moonbeam, how you can get started. We already saw MetaMask and Remix. We're going to see how you can configure Truffle and Hardhat, and we do have some Chainlink and other kind of DApps to show you around. So let's say you're a developer and you want to get started with Moonbeam. There are two, let's say you're just starting, there are two paths that you can take. You can either build a development node or you can go to the testnet Moonbase Alpha. The development node is a very cool way to get started because it's kind of ganache, right? It provides instant seal. This means that a block gets produced every time there's a transaction in the pool. And this is super fast for development. You can send 100 transactions in less than 3 seconds or so. There are two ways to build a development node. One of them is with a Docker image, or you can clone the repo, compile the binary, and run the binary. The Docker image can get you started in a matter of less than 2 minutes. Building the binary, it's cool, but it takes roughly 30 minutes. So, depending on your machine. So we tend to, tell people that the Docker is the right way, but you can do both things. On the Moonbase Alpha side, we provide an HTTP and a WebSocket endpoint. We do have a token faucet in Discord that you can get some tokens to start playing around. And we do have staking and governance features there if you want to also play around with those features as a developer. So if you want to build a development node, like I mentioned before, the Docker way is the fastest way to get started. If you have Docker installed, basically you just run this command, and it'll pop up a Moonbeam development node where you have two endpoints available on localhost. The HTTP is in port 9933. The WebSocket endpoint is in port 9944. I just added some extra flags that you can run on the development node. These are really helpful in case you want to do different things. For example, let's say you want to create you don't want to have this instant seal feature. You want to have a block produced every X seconds. You can use a -- sealing flag and provide the time in milliseconds. And there are other flags you can see on the screen that I'm not going to go through them all, right? If you want to build the binary, you can just clone the tutorial, the repo, and build it using these steps. Like I mentioned before, it takes roughly 30 minutes. It might take a little bit less or a little bit more, depending on your machine. And then you can run the binary using this command down here. For the testnet, it's even more straightforward to get started with the testnet because they're already an HTTP and WebSocket endpoint. So for example, MetaMask, if you want to connect to it, is super fast. For example, I provided some code snippets here. Let's say you're using the Web3 JavaScript library. You just import the npm package, and then you can just create from the Web3 constructor, create your Web3 instance by providing the HTTP endpoint, right? It's just that easy to basically port the Web3 JavaScript library to Moonbeam. So instead of using like an Infura or Alchemy API, you just put the HTTP endpoint from the testnet, and that's it. That's the only change you have to do on the Web3 JavaScript library. On Ether.js, depending on the Json Rpc provider that you're using, we tend to recommend people to use the static Json Rpc provider. You need to pass in the HTTP endpoint, the chain ID, and the name of the network. This is not entirely necessary, but if you're using the static Json Rpc provider, this is what we recommend. For Truffle and Hardhat, you might have just guessed already that you just need to define a Moonbase provider. You can actually a Moonbase network. Sorry, you can use HT wallet provider by just giving a private key and the HTTP endpoint and the network ID. And with the Hardhat, it's super similar. There's not a lot of stuff that you need to change. Just define a different network. with the configuration that you see on the screen. So basically, like I mentioned before, it is just that simple, right? If you already have a deployment script that is using Truffle or Hardhat, it's just defining a new provider and just deploying, and it might take literally 2 minutes to change your configuration to be able to deploy on Moonbase Alpha. Yeah, so what I want to do now, we still have a lot of time. So what I want to do now is go through some examples, right? So we do have some Ethereum dApps running on Moonbeam. I'm going to go through them a little bit so you can see more or less how Ethereum compatible we are, basically. And so let me just do this. And yeah, like I mentioned before, you saw Remix. You can see at the top part of Remix that I have the injected Web3 provider connected to the testnet, which is on chain ID 1287. You have MetaMask. MetaMask is connected to Moonbase Alpha, as you might have seen on the top right corner. I do have, for example, some dev tokens, some ERC20s that I've deployed, and you can see here our 0x Moon token that, of course, you can just use MetaMask to transfer to another account that you have, and we can just provide here, let's send this person 1,000x 0x Moon tokens. You can see here, I can just click next, confirm, and the transaction is queued. And if once this transaction is confirmed, we can actually go ahead and view not an Etherscan. Oops, sorry about that. Not an Etherscan, we could because we're not there yet, but you can copy the transaction ID and go to our Explorer that we're running, which is Blockscout, and just go ahead here and paste it. Right? I mean, the transaction has not been mined yet, but usually it takes 12 seconds or so. It might take 2 blocks because we're getting a lot of transactions per day nowadays on the testnet. But this is more or less how it would look like. There you go. It's already mined. Well, it's not mined because it's in Polkadot there's no mining, right? But it's already included, and I can just go ahead and search for this transaction on the Block Explorer, and you can see here that hopefully you can see this, that this is already this is the nonce, the transaction fee, transaction speed. And you can see here that it was just, a recipient of 1,000. Well, I mean, some tokens here. So the easiest way to get started connecting MetaMask to our testnet is that we've included this latest MetaMask feature that you can just create a button, and just in our docs side that you will find in our website, you can just click here and connect MetaMask. And there will be a pop-up saying, "Hey, this website is trying to configure MetaMask," and you can just click next, and MetaMask will be automatically configured, so you can just get started super quickly, right? If you're old-fashioned and you want to just go ahead and do it yourself, you can go to one of our tutorials that is Integrate MetaMask, where we have also the button, but we also have a step-by-step guide of how you can get started and connect it to Moonbase Alpha, the old-fashioned way of configuring the network yourself. But yeah, basically it is that easy to get started. You can see here that I already have less 0x Moon tokens. And so yeah, let's go ahead and check some dApps, right? So the first one that I want to show you, there's a question, nice. Can we deploy our dApp build on Moonbeam to web using Web3, same as we do with Ethereum? Yeah, exactly. You can do it. That's the beauty of Moonbeam. You can basically just define, let's say that you're using Truffle or Hardhat, just define a different provider, and that's it. I mean, you've deployed your contracts to Moonbeam, and from the dApp side, from the front end, I'll just show you how easy it is with actually this example. So what we see here is that we have the Moonlink Oracle dashboard, and this is basically an Oracle that a dashboard that we've created as an example for Chainlink on Moonbeam, right? So Chainlink provides 2 ways of getting the price feeds or the price data on chain. So one of them is a data price feed, and this is only doing read operations to smart contracts. As you can see here, we have token pairs BTC, ETH, DOT, KSM, and our Chainlink configuration updates the price every hour, or if the price changes more than 1%, it will update it as well on chain. So this is the price information that you can see here. The basic request model is a different way. You can actually see how the price of BTC has dropped, because nowadays it's roughly 45K, and now this was updated May 12th. So you can see here that we can actually request a new price of BTC if we just copy this job ID and we submit a transaction. Oops, this happens when you have MetaMask like super zoomed in. So yeah, exactly. So I'm just looking at the answer. Yeah, you just need to change your RPC in MetaMask, and that's it. It's super convenient, and this is what I mean. That me being a developer relations engineer, for us, it's truly important that the experience that you have is exactly the same as in Ethereum, right? So we truly appreciate any feedback that you have while deploying your contracts or deploying your DApp to Moonbase Alpha. Because for us, like I mentioned before, if you hit any roadblocks on Ethereum compatibility, we're not doing our job well. So we're trying to push for that really hard. So yeah, I mean, if you want to see the code of this dashboard, you can click here. And this will take you to a GitHub repo that we prepared with all the code that builds this dashboard for you. Just to let you know that this code is not something fancy or anything. It was written in a way that is very understandable. And one of the things, for example, that you need to change in terms of the provider is that in this case, what this code snippet does is that, hey, if it detects MetaMask and MetaMask is connected to the chain ID that Moonbase Alpha represents, just use the MetaMask provider, right? But if we don't detect MetaMask, I'm just defining the Ether.js static Json Rpc provider with the Moonbase Alpha kind of information. So this is a way that it might just be different if you, for example, want to provide compatibility for Coven in our testnet. You might have to change this snippet and also this snippet depending on what you want to provide to your front end and your users. But this is basically it. This is like the main code snippet that will provide the Web3 instance that you need in order to get started. And like I mentioned before, you can either use it with MetaMask and use a provider that is injected by MetaMask depending on the network you're connected. And on the other side, you can just provide a static provider just in case that user doesn't have MetaMask. Because, for example, in this example, this information is all read operations, right? So the user doesn't need to send a transaction, so it doesn't need MetaMask signer. Right, so only by providing like this HTTP endpoint, you will be able to see this price information, even though MetaMask is not installed. And down here, you can see that this price was already updated, and you can see the timestamp here. And then this now represents the same, more or less the same price information as this one, right? All right, hopefully this is more or less clear. Like I mentioned before, we provide a lot of code snippets and repos in case you're interested and you want to check this out for some help, right? Another DApp that we've created, and this is cool in case you want to use you want to deploy kind of like a DeFi kind of thing or a DApp that uses ERC20 tokens, is that we've created an ERC20 token faucet for the testnet. So there are basically 8 tokens that represent each planet, and the 9th token is for Pluto because Pluto is not a planet anymore for some reason. But yeah, basically the idea is that you connect MetaMask to this DApp, and you will see your balance. You can see here that I have no Mercury token balance or no Venus token balance, and you're actually limited to 100 tokens every hour. So the idea is that, for example, let me go ahead and mint some Uranus tokens. So I can go ahead down here, click on the planet name, and then just submit transaction. And once again, MetaMask will pop up as it would on Ethereum, right? So this is a very Ethereum-like experience. And I'll just confirm the transaction. Once the transaction is confirmed and it's included in a block, we will have now 200 tokens. And then this Boolean will set to false because I have to wait another hour or so to be able to mint. So we've provided all the token addresses here, just in case. There we go. You can see that I have already 200 and this Boolean is set to false. We provided all this token addresses in case you want to implement them in your solution, your DApp or anything. And you can tell people to come here to mint tokens and interact with your DApp if they want to. So as an example of this DApp implementation, we can go ahead and go to Moonbeam Uniswap. So this is basically a Uniswap v2 deployment that we did on our testnet. And we called it Moonbeam Swap for fun, but it's just a way to show people that, you know, building on Moonbeam, in this case, a Moonbase Alpha, is really easy, and it's really easy to port projects. If you already built a DApp for Ethereum, you know, deploying that DApp to Moonbase Alpha or Moonbeam is just very straightforward. As you can see here, I have Moonbeam Swap. I have a balance of 340 Earth tokens, and I can swap some 10 Earth tokens, you know, for almost 12 Merc tokens. You can also create a pool, add liquidity, and, you know, for example, let's add liquidity to the Pluto and Saturn, right? I'm the first liquidity provider, so this means that I'll be actually creating the pool. So I can just go ahead and add 10 tokens of each. I'll have to approve each of these tokens, you know, the Uniswap contracts as an ERC20 spender. So I'll just confirm this. And confirm this as well. And we'll have to wait a little bit until this is approved. And there's another comment. Can you please tell us how Substrate is different from layer 2 scaling of Ethereum? And does it have a competitive transaction cost and speed than layer 2? Yeah, so this is actually a really good question. And Substrate, you shouldn't see Substrate as a layer 2 solution, right? Substrate it's more like Geth or Open Ethereum, right? It's like the underlying kind of implementation of the blockchain. And Moonbeam, a lot of people get confused between Moonbeam and layer 2. But Moonbeam is actually like a layer 1 as well, right? So you're deploying the contracts directly to Moonbeam, and Moonbeam will be like the mainnet, right? So it will be directly like implementing a solution on Ethereum mainnet, but it will be, you know, on Moonbeam, and with that you will have access to the whole Polkadot ecosystem, basically. So in terms of transactions cost and speed, we're targeting 6-second block time on mainnet deployment, even though, you know, right now our testnet is 12 seconds, and this is due to some problems in the consensus mechanism right now that's being tested. But we hope that we have a target of 6-second block time on both Moonbeam, that is our Polkadot deployment, and Moonriver, which is our Kusama deployment. In terms of transaction costs, it's kind of hard for us to talk about transaction costs right now, because, you know, there are a lot of still improvements being done to the Moonbeam technology stack. Currently, right now, what we have in our testnet is that per block, we have a 15 million gas per block limit. So this actually, it matches the same as Ethereum right now, even though Ethereum just increased it to from 12.5 to 15 million. But basically, we hope to increase these by a factor of 4 at least. So we're talking about a 60 million gas limit per block, and we would have a 6-second block time, right? So we like to say that we expect transactions to be a lot cheaper than on Ethereum, because we're providing a bigger room for transactions to be included on a block, right? So it's kind of difficult for me to talk about specific numbers, but, you know, we expect, because of the things that I've just mentioned, to be much cheaper to deploy or interact with Moonbeam than with Ethereum mainnet. So hopefully this answers the question, even though it's not as straightforward. But I just want to make another point into saying that Moonbeam will not only you will able to deploy to Moonbeam, but you will able to access other parachains or the assets of other parachains in the Polkadot or Kusama ecosystem through Moonbeam. And that is also another important topic, right? A lot of people ask us, hey, what's going to happen when Ethereum 2.0 comes and the gas price, you know, gets marginally lower? What's going to happen with Moonbeam? And we tell them, hey, yeah, but Moonbeam is we don't see ourselves as an ETH killer. You know, we see ourselves as a gateway for Ethereum projects to access the Polkadot or Kusama ecosystem. So I'm going to create a pool, and you can see here that I have my MetaMask pop-up. I can just confirm. And, you know, this is going to take a while, so I'm just going to go back, and I'm going to do the swap as well, right? So I'm going to swap Earth tokens for, was it Merc tokens? There we go. And you can see that basically what we did is that we included this ERC20 tokens in the token list by default that you usually have on Uniswap, right? So I'm going to go ahead and put 10 Earth tokens, and I'm going to click on swap. confirm swap. And I'll just confirm this. All right. And by the way, the pool was already created, but I totally forgot what was the two tokens that I selected. So either way, the pool that I just added liquidity to is just created. The cool thing about this as well is that I can just go ahead and, for example, check, right, the add liquidity transaction. I can copy the transaction ID and paste it on our Blocks Cloud implementation. You should be able to see everything related to this, right? So I'm interacting with this. You can see all the contract, the call that was used in the Uniswap V2 contract, which is the add liquidity method. And you'll have everything related to the logs, the raw trace. So this is, like more or less like an Ethereum experience, where you have a lot more information for developers to play around with in terms of the contract interaction, right? So as you can see here now, this swap was already confirmed, and I have some Merc balance now because I swapped some tokens. In terms of another DApp, this is Balancer. Once again, we announced that Balancer is coming to Moonbeam, and we'd really like to, we did this implementation to showcase basically how would this look like, right? So you can see that I have also, we deployed the pool management UI and this pool management UI. The cool thing about this is that this dashboard here that you see on the main screen, this is actually using the Balancer subgraph, right? So this basically showcase that we're able to use all these Ethereum tools to interact together as they would on Ethereum mainnet, but this is on Moonbase Alpha, our testnet. So this information is fed to this dashboard via the Balancer subgraph. That is basically the graph is deployed on our testnet, and it's running nodes, and you can launch subgraphs and fetch information from your smart contracts and display it nicely like it is on this dashboard. So what I'm going to do, in here you can create a pool, you can wrap some dev tokens into wrap dev and so on. But what I'm going to do is that I'm going to show you guys once again that I can swap some 10 Earth tokens from some Venus tokens, and we can see the order routing. That it's really cool because what we're looking at is that this is telling me that it's going to do this swap using 2 pools, right, to get you the best price possible. And if I actually increase this, oops, I don't have enough balance. This is actually going to use now 3 pools to get you the best price possible. So I'm going to go ahead and I'm going to click on swap, MetaMask pop-up. I'll confirm this transaction. Oh, by the way, I didn't mention this, but on the testnet currently, you can use gas price is 0. So you might have noticed on my MetaMask, every time there's a pop-up, the gas limit, it's whatever number, and the gas price is set to 0. This might change in the future, but currently still you can deploy contracts without having any funds because you can set the gas price to 0. So you can see here now that I should have roughly 9.8 Venus tokens, and if I go to MetaMask, I see my Venus tokens right here. So yeah, this is pretty cool. It's to show you a little bit of composability of different things working together. Show you that you can actually deploy stuff that are on Ethereum to Moonbase Alpha and play around with minimal changes, just add compatibility. Usually it's more difficult to add compatibility for the front end than for the smart contracts themselves, right? But this is some different stuff around that you can see that how they work on Moonbase Alpha. And once again, we've added actually all the ERC20 tokens just so people have, a way of like common good ERC20 tokens to play around and to test in their implementation. Another cool DApp that we have here, it's actually a bridge that communicates Moonbase Alpha to either Coven and Ethereum. We do have some documentations written about this bridge, but what you can do is mint ERC20 sample tokens, and here you can mint tokens. Actually, let's go ahead and do it. Because the bridge works with some assets that you need to register, right? And so for demo purposes, we've registered this ERC20 token so people can just test the bridge functionality and send tokens from Moonbase Alpha to Coven, from Coven to Moonbase Alpha, and the same with Ringkey, right? So it's just, we decided to do 2 test and implementations. You can see how now I have 8 ERC20 sample tokens, and I can go ahead and click here, I'm going to send 2 ERC20 sample tokens just to my same account, and I'm going to start the transfer. And I'll just, oops, it's telling me the gas price is 10. I'll just leave it like that, but you can put 0 on this will work. And this UI is a very nice and clean way to interact with the bridge, but you can also interact, of course, via the smart contracts. We have all the information in our doc side if you're interested and want to build something around the bridge. So yeah, this actually, it's already confirmed. This should start initiating the transfer. There we go. This will take some minutes because we need to do, so how the bridge works is that there's some stuff going on the origin chain, which is in this case in Moonbase Alpha. And then there's some stuff going on Kovan that the relayers need to sign and vote to make sure that this is a valid transaction. And then they'll send a transaction on Kovan saying, hey, unlock this token for this person, right? So we'll come back to make sure that this actually went through. All right, so I still have some time, and I want to spend some slides. Well, actually, yeah. So some of the DApps I just showed you are in here in case you wanna check them out. I'm going to provide this presentation should be accessible via this link. And if you want to check them out, we do have the repos for the ERC Minter, the Moonbeam swap. Actually, we just released a blog explaining how you can port Uniswap v2 to Moonbase Alpha, and the Moonlink dashboard. Sadly, I haven't had time to provide the information regarding Balancer, but this is something that we plan to do in the future. So yeah, I mean, all this sounds really cool. You got me, Alberto. You got to me. I want to start working on Moonbeam. How can I do it? We have a really extended documentation side where you'll find examples of how to connect MetaMask, how to use Remix, how to use Truffle and Hardhat, Ethereum libraries, Web3 JavaScript, Ethers, and Web3 Python, some different Oracle solutions, the bridges. We have a couple of indexers that are working on Moonbase Alpha. This is the Graph and Covalent, and we have a lot more. You can check out our Moon Builders workshop, Getting Started with Moonbeam. We have already 2 more episodes, one with the Chain Bridge solution. It was presented by Greg from ChainSafe, and the other one from Ganesh from the Covalent team. This is super cool if you want to check those out. And just to wrap it up, I mean, we still have some time, but I want to speak a little bit about the challenges, right? So we have a couple of bounties or challenges. The first one is pretty generic. It's just to build a DApp on Moonbase Alpha. Of course, the DApp that brings the most value to the testnet, it's gonna get the prize. But the idea is just create a DApp. You can use any of the integrations that I've presented to you today. This is Oracles, bridges, indexers, or whatever. The DApp should be available to all the tested users. So anyone in the testnet should be able to use it, getting some dev tokens, using the Minter DApp, and get some ERC20s to interact with your DApp. And for us, like I mentioned before, it is really important that you write some documentation, explain how was your experience deploying to Moonbeam, any issues, any suggestions. Like I mentioned multiple times, for us, it's really important the developer experience that they're getting. Is it similar to Ethereum? Where are the roadblocks? Where can we improve in terms of documentation as well? So basically, those are the 3 kind of like requirements. It's super simple and straightforward. Just build something on Moonbeam that it's cool. Brings value to the community, and just and just provide some feedback basically. The challenge number 2 is it's not that it's more challenging, but it's something that it's more unique, right? Because one of the features that Moonbeam offers natively is staking and governance, right? So those are features that are not available on Ethereum. So the cool thing about Moonbeam is that it's this Ethereum-compatible kind of environment, but have this like Substrate or Polkadot features such as staking and governance. So what are the staking precompiles? So what am I talking about? It's basically to access the staking features, you need to go through the Substrate API. And if you're not familiar with Substrate API, I can just provide a really quick rundown of what it looks like, right? So this is the Polkadot.js interface, which is basically what people are using to interact with like Polkadot Substrate-based nodes, right? So if you go here and you go to test networks, you can actually connect to Moonbase Alpha. And basically, this will show you everything related to, for example, democracy you have right here, right? So this is all the democracy kind of proposals that people are doing, and you can go ahead and vote on them and so on. But to access the staking features, you have to go through like extrinsics and send transactions, using the parachain staking, and then select the function that you want to use. So this is not a nice experience. So what we're trying to do is to create a way that Ethereum developers can actually access this kind of like functions of the parachain kind of features, right? How can I nominate people? How can I put more money behind coallators, which are block producers? So the idea is that I lost the, oh, there we go. So the idea is that instead of accessing the Substrate staking features via the Substrate API, actually you can use the Ethereum API and access it via some staking precompiles that will launch, right? And it will be in a kind of long-lived address. You can go ahead and you will have some functions that are actually mapped on our side through the EVM palette and the Substrate API are mapped on the code to actually create this extrinsics, staking extrinsics for you. And so you're actually able to access the staking features, right, via like an Ethereum kind of like, environment, let's say it like that. So this is an idea that it's cool because, Ethereum developers don't need to learn about the Substrate API or Substrate tools, but they can use the regular tools and just access the staking features, right? There's this Crowdcast link. This was part of our Illuminate 21 event, where Joshi and Amar talked about the staking precompiles, how do they work, and they even presented like a DAO kind of example of how to use the staking precompiles to access the staking features, right? So, well, I mean, I guess you more or less understand the idea. The idea would be to create a DApp to interact with the staking palette using the staking precompiles, right? So don't worry about the Substrate API. You don't need to learn anything about that. The staking precompiles are not currently available on our testnet. So they will be available on Moonbase V8 it is targeted for May 24th. But let's say that, I really want to work on this. I really want to test it out. How can I get started? So in the meantime, what we did is that we're going to prepare a branch on our Moonbeam repo, and you can actually build a local node from that branch and then get started on a local node. And then once we launch Moonbase V8 and the staking precompiles are available on the testnet, you will just be able to change the RPC URL to the testnet and test it there. So yeah, the idea is that you could create a DApp that it shows, some buttons and stuff to interact with the precompiles, and you can get more information as well as a dashboard, like, hey, some information regarding staking and so on. There are two kind of like places that you can learn more about this. In our documentation website, you have the staking menu, and here you can learn a little bit more about how staking works, the general definitions, what is a collator, what is a nominator, everything related to what you need to learn should be here. And also you can learn how to stake. This is just to get familiar with how the staking works, but this uses the Polkadot.js, right? This uses a Substrate API basically. But this will help you a little bit to get started on understand a little bit how it works. Regarding Gitcoin, we've provided a lot of information and a lot of links and the bounties to help you get started. And we're always active on our Discord channel if you need any help. We'll also be looking at the 0x Discord channel just to make sure that you can get all the help that you need. In terms of the staking precompiles challenge, I've put as much information as possible for you to get started. Some Solidity interface, the presentation from Illuminate, some DAO examples from the presentation, and some more other kind of like blog posts and stuff where you can read a little bit more and understand how this works. You can see that the address where the precompile will live is basically this address that you see on the screen. So yeah, I think that is pretty much all I had from my side. I don't think there are any more questions or comments on the chat. So yeah, I mean, there are a lot of places that you can actually go ahead and how you can get in touch with the Moonbeam team. You can visit our website, moonbeam.network, our documentation site. We're very active on Telegram, on Twitter, if you have any developer-related questions, you can go to our Discord channel, or also you can shoot them in the CRX channel, as you might have guessed. Feel free to communicate with us. We're very active. We have a 3-person developer relations team that our idea is to provide the best onboarding experience to Moonbeam. And don't be afraid. Just start playing with Moonbeam, and don't be skeptical about being kind of like a Polkadot parachain. Feel free to shoot us any questions that you have. And yeah, super excited to be part of the hackathon, and excited to see what you guys come up with, and to judge your bounty submissions. So yeah, I mean, I don't know if there's no more questions about challenge 1. All right, sure. Let me go ahead and present. Oh, okay. So I'm just gonna take some minutes, Antek, and there was a question related challenge 1. So basically, the challenge 1, it's super simple. It's either more straightforward than the other one, because the idea is that you should build a DApp that uses any of the integrations that we provide. So even the graph or Covalent, or oracles like Chainlink, Band, Razor, or Chainbridge implementation. So build a DApp, a front-end DApp that just uses any of our integrations and provide value to the testnet or the community. Just basically, it's that simple, right? It's very straightforward. We don't have any specific requirements. Just have fun, build something. And also another part is provide feedback, right? Write a small document or page explaining how was the experience, if you had any roadblocks, any suggestions for our documentation. Like I mentioned before, the feedback for us is essential, because we want to provide a seamless Ethereum experience on Polkadot, and feedback is like the best way for us to improve on those terms. So yeah. All right.
Yeah, hey, sorry, we had a short glitch here. Yeah, Alberto, thank you very much for your presentation. You gave a lot of useful details on your bounties and the project. So we're gonna take, I think you answered all the questions, is that correct?
Yeah, I think so, yeah.
Great, so we're gonna take a short break now. We're gonna have Jakub from Golem next at 2 p.m. CST. Then we're gonna have Alex from Balancer, and finally, for the end of the day, we're gonna have a workshop with Patrick or Harry. I think it's Harry from Chainlink. So stay tuned for that, and as always, all the teams are waiting for your questions on Discord.
Thanks a lot. Have a nice one.
Thanks, Alberto. See you.
Bye.